Integration of function y is equal to f of x with respect to x is given as integration of f of x dx. Here, this symbol indicates the integration with respect to x. If you want to find out integration of function y is equal to f of x, consider the graph of the given continuous function y is equal to f of x. So we have a curve representing y is equal to f of x, and we are interested to find the area between the curve y is equal to f of x and x-axis. So we can divide the entire area into the rectangles having equal thickness. So the thickness of rectangle is delta x, while height of the rectangle is given as the y coordinate at point of the curve. So the area of the first rectangle is given by a1, which is the product of y and delta x. Similarly, area of second rectangle is a2, third one is a3, and that of the last rectangle is an. So we can find out the area between the curve y is equal to f of x and x-axis, but there are some area which are not covered by the rectangle. So we can say that the area between the curve y is equal to f of x and x-axis is approximately equal to sum of the areas of the rectangle. Area which are not covered by the rectangle can be reduced by increasing the number of rectangles. So what happens if we integrate a function f of x with respect to x? Integration of function divides the area between the curve y is equal to f of x and x-axis into infinite number of thin rectangles and add their areas to get the total area between the curve and x-axis. So here we have got the curve representing the function y is equal to f of x, and the area between the curve and the x-axis is divided into infinite numbers of thin rectangles. And the thickness of each rectangle is very small, that is dx, and the height of rectangle is y, which is the y coordinate of the curve at that particular point. So now consider again the function y is equal to f of x, and considering a single rectangle having thickness dx and height y. So this rectangle will have infinitesimally small area dA, and it is equal to the product of height y and thickness dx. So we can add similarly all the rectangles which are occupying the area between the curve and the x-axis to get the overall area between the curve and the x-axis. So the overall area is given by addition of all small areas of rectangle, and that process of addition is called as integration. So integration adds the small areas of rectangle to form the overall area between the curve and the x-axis, which is also equal to the product of y and dx. So the overall area between the curve and x-axis is given by the integration or addition of small area of rectangle, which is equal to y dx. We can write down the integration of function f of x dx as the area between the curve y is equal to f of x and x-axis.